Morning, everyone. My name is Y. Pawan Kumar. I am pursuing BTech in Srinivasa Ramanujan Institute of Technology. Today, my topic is Clausius-Mosotty equation. Clausius-Mosotty equation. Explanation of Clausius-Mosotty equation. Introduction to Clausius-Mosotty equation. The Clausius-Mosotty equations connects the atomic level properties with observable macroscopic electrical behavior. It relates the dielectric constant of a material to the polarizability of its molecules. This equation is important in material science and electromagnetism. Clausius-Mosotty equation. This equation is important in material science and electromagnetism. ER is equals to relative E R naught minus 1 by E R naught plus 2 is equals to NE AE by 3 E naught. ER is equals to relative permittivity. N is equals to number density of molecules. Alpha is equals to molecular polarizability. Z naught equals to vacuum permittivity. Clausius-Mosotty equation involves in two concepts: polarizability, a measure of how easily the electron cloud of a molecule can be distorted by an external electric field; relative permittivity, a measure how much a material can be polarized compared to vacuum. The Clausius-Mosotty equation creates a bridge between these two concepts. Derivation of Clausius-Mosotty equation. Begin with the polarization. Consider the local electric field acting on a molecule inside a dielectric. Use a dipole moment and total polarization. After substituting and simplifying, we get the Clausius-Mosotty equation. Here we can see applied electric field E, polarization P, dipolarization field. Here we have plus plus increment. Here we have minus minus decrement. Mm. Here we have applied electric field E plus 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 induced charge in dielectric. Applications of Clausius-Mosotty equation. Useful in dielectric material design. Helps predict behavior of gases and dilute solutions. Used in optics, chemistry, and electromagnetism to understand dielectric responses. Limitations of Clausius-Mosotty equation. Assumes weak interaction between molecules, valid mostly for gases, not accurate for dense liquids or solids where strong interactions exist. Assumes, assumes spherical symmetry in molecules. Uses of Clausius-Mosotty equation. Analyzing gases and dilute solutions, especially useful for gases where molecule interactions are minimal, can estimate molecular polarizability from measurable dielectric constant. Linking microscopic and macroscopic properties connects atomic level polarizability with bulk dielectric behavior, enabling deeper material understanding. Calculating polarizability if the relative permittivity and number density are known, the equation allows calculation of molecular polarizability. Conclusion. The Clausius-Mosotty equation establishes a relationship between the macroscopic dielectric constant relative permittivity of a material and the macroscopic polarizability of its equation molecules. It helps bridge the gap between atomic molecular properties, and bulk dielectric behavior. This equation is fundamental in dielectric physics, materials science, and electromagnetism, providing insight into how materials respond to dielectric field, especially valid for gases and dielectric materials where intermolecular interactions are minimal. Minimal. Okay, thank you.